This is a sigmoid function. This is one of the most important functions in AI. You can see this being used in a lot of places, including neural networks as an activation function, or even in logistic regression, which is a part of classical machine learning. Let me quickly teach you why this is one of the most important functions and how it works. Let's dive into it. So, if you look at the function, it says 1 divided by 1 plus e power minus x. So here is how the graph of sigmoid looks like. So here on the y-axis, it is sigmoid of x, and on the x-axis, it is the x value. So you can see here, irrespective of whether the value of x is negative or positive, the sigmoid value will always lie between 0 and 1. The minimum of the sigmoid function is going to be 0 and the maximum is going to be 1. Why is that happening? For that, you'll have to take a look at the graph of the exponential function. So if you look at the graph of the exponential function, you can see that the domain of the exponential function, which is nothing but the input or x value, could be anything. It could be a negative value or it could be a positive value. But the output of the exponential function will only be positive or 0. So let's take the first case. When x is equal to infinity. So the sigmoid function will become 1 plus 1 divided by 1 power e power minus x, which is equal to 1 divided by 1 plus e power minus infinity. So e power minus infinity, it's going to be 0. So this will be equal to 1 divided by 1 plus 0 equal to 1. So when the x value becomes huge, or if it is a huge positive number, very large positive number, the sigmoid squishes it and reduces and maps it to a value of 1. So let's take the second scenario. Second scenario, x is a large negative number. When x is a large negative number, what happens is the sigmoid will become 1 divided by 1 plus e power minus of minus infinity. This is nothing but 1 divided by 1 plus e power infinity. So e power infinity, if you look at the graph, you can say that as x go towards infinity, the value of e power also goes towards infinity. So this value becomes infinity, and anything added to infinity is also going to be infinity. So it's going to be 1 divided by infinity, or an extremely large number. So that is actually going to be 0. So you can see that irrespective of what value that you plug into the sigmoid function, it will always lie between 0 and 1. So why is this useful in AI? So let's say you built a neural network. So this is how the neural network looks like. And then you're trying to predict whether an image that you're passing as input contains the picture of a cat or not. Right? So you pass the image to the neural network. The neural network tries to learn all the weights which are hidden in the layers. And finally it comes up with a prediction. So the one thing that you always have to remember is the input to a neural network is going to be a number, and the output from a neural network is again going to be a number. So the output that the neural network gives, or the output of the final neuron, could be any value. It could be a positive value, it could be a negative value. The value actually depends on the weights that each of these layers learn. So you want it to be in a very interpretable manner. So you want the output to be a probabilistic value, where if the image actually contains the picture of a cat, you want it to be 1, or if it doesn't contain the picture of a cat, you want it to be as close to as 0 as possible. right? So what you do is you pass the output of this function to a sigmoid function. So that will give you the probabilistic value, or a value between 0 and 1. So if you think about it, given any input, you can map the input to an output through a sigmoid function. So if you found this video useful, please consider subscribing and like and share it with your friends. Thank you so much.